Okay, so lean in the lab. What are the goals of lean in the lab? They're the same as lean in manufacturing or anywhere else, which is improving performance via the introduction of flow and the elimination of waste. That's a BSM statement. You won't see that anywhere else, but we happen to think it's very appropriate and correct. But labs are not the same as manufacturing. I've said this already. Typically, you have more volatility, variability, less process reliability, in that in lots of cases the test is at the limit of what's possible, and you get lots of out of spec and out of tolerance results, and you have to deal with that. You come across tests where it'll fail system suitability twice before you get it going, and you're living with some things that are not ideal, and some you can fix, others you have to be pragmatic about when you design the sort of systems we're talking about, and you just face up to the fact that you haven't got a great process. And the most important difference in labs is that the task cycle times, in other words, to run an assay, is much longer than the sort of short cycle manufacturing that lean was originally conceived for, which is why you have to reinterpret it differently. In other words, if you're going to do lean and you do a spaghetti diagram of your lab, and you reduce the number of steps an analyst walks in a day, you haven't really done much. I happen to think it's healthy to do a little bit of walking, and it's not important in the context of a very long assay or longer assays. Whereas if that's something on a manufacturing floor, which is much shorter cycle time, then a walk it can be a significant proportion of the overall. So don't get trapped into spaghetti diagrams. And by the way, you can do flow without moving your equipment. It's not ideal. It's much better if you can line up all your equipment in a way that flows naturally better, but you can still flow, even if it's over and back because you have fume hoods or whatever, or in certain locations. Okay, there's generally a complex mix of routine and non-routine testing. So as well as the stuff that gets the batches out the door, there's usually a whole heap of other tasks and activities, cleaning validations, new method validations, projects, the new products, whatever, there's all that stuff going on. And generally most labs just mix those two things together and end up doing neither very well. We believe you should separate the routine and the non-routine and treat them differently, because it's a different skill set to be good at those two things. Generally less operational excellence or productivity focus. It's generally not the natural or main focus of labs. It's more about the accuracy of testing, and you need to shift that pendulum a little bit, is our view. The guiding principles of lean still apply, but there's lots of constraints in the application of standard lean tools. So if you've ever tried this and looked at some of the memory jogger stuff and thought, it makes no sense in a lab situation, you're probably right. Okay, but don't get put off by that. Lean can and should be applied to labs and will bring significant benefits. So single piece flow, which is a mantra lean, is generally nonsense for a lab. Generally because the stuff that you do per assay, as in a system suitability or whatever, or dilutions or whatever, or making up reagents or whatever it happens to be, is a big proportion compared to the per run time for each sample. So, you can't blindly follow single piece flow. Standard line balance, work content charts, spaghetti diagrams, even value stream maps don't work well, if at all, in lab situations. Generally, value stream maps are not at all detailed enough. You need to go to a lower level of mapping, which is a TQM type map or something like that. 5S is not lean. I think you've heard me say that already. And flow is possible and highly desirable, but it takes a lot of creativity to achieve it. And pull is a little bit different in the lab. But you can reinterpret pull as testing according to customer demand. And in most labs, that's not a big issue, that you receive samples in the order in which they're required, but not always. Significant wastes, are different in labs than they are in manufacturing, and they're hard to reduce. And I'll come back to that later.